So thank you everyone again for joining us. Today we're going to be talking about the topic of ocean technology. So we know that oceans play an important role in how they regulate the Earth's temperature. They absorb carbon dioxide, they support biodiversity and many people's livelihoods. But we're only just starting to realise the extent to which the blue economy can impact climate change. There was a high-level panel for sustainable ocean economy, which estimated that they think the ocean economy, or the blue economy, as it's often referred to, can deliver 21% of the greenhouse gas emission reductions that we need to meet the Paris Agreement target of limiting global temperature rise to 1.5 degrees. It also suggested that an increase in sustainable food production from the oceans would be able to also help to meet the needs of our growing global population and hopefully reduce the pressure on land-based food systems as well. So a double win. Today, the ocean economy is estimated to be worth over $1.5 trillion a year globally and provides currently over 30 million jobs. But thanks to a growing interest in the blue economy, there has been a prediction that they think that will double in size and that the ocean economy is likely to be worth over 3 trillion by 2030. So definitely an exciting, growing, important and impactful space that I'm really glad we are covering today. So today, we're going to hear from two pioneers in this space. We're going to be hearing from Clement from WaveX, who is going to be sharing how their technology can harness the power of the waves to make clean energy in an efficient and a non-destructive way. And we're also going to be hearing from Mike from ACUA Ocean, who are building zero carbon emission autonomous surface vehicles that rove the surface of the oceans and collect ocean data and help us to protect and manage our oceans. So without any further ado, I'm going to pass over to Clement, who is going to talk you through what they are doing at WaveX.
Can you hear me now? Great, so thank you. I'm Clement. Can you see my screen? All right, thank you. So I'm Clement, I'm co-founder of WaveX, and I'm a bit nervous because I'm not really familiar with this exercise, but what I am familiar with is WaveX, and so I'm going to talk to you about what we do there. Are my slides going to? Yeah, okay, they work. So at WaveX, we harness waves to restore beaches and generate electricity. Our work environment is coastlines. And coastlines are probably the last place on Earth that we humans can't harness. They are fluid areas shaped by nature. And so far, we've tried to work there against nature. And we have failed. But why is that? Because we're used to working with rigid structures. In a fluid environment, rigid structures don't do well. They either get damaged by storms or damage the environment. Nature uses a much softer approach. In nature, the seabed gently changes what happens to waves, absorbing, redirecting, or reflecting their energy. That's what we do at WaveX. We replicate natural processes thanks to flexible membranes buried under the seabed. It's nature-inspired, it's eco-friendly, it's affordable and scalable. So what do we do and how do we do this? We can create sandbars by inflating flexible structures under the seabed. This reduces coastal erosion in a number of ways. For example, by dissipating wave energy on top of the sandbar. We can do even better. In July, we have shown that waves can quickly transport sandbars onshore. All we have to do is create the sandbar in the right place at the right time. And we're really proud of this result. It's never been shown before. And it's much better to use waves to replenish beaches rather than using trucks or dredges. It's sustainable, it's affordable, much more eco-friendly. But how do we do this? How do we actually install our flexible structures that are able to raise these sandbars? Here again, the answer has come to us from nature. So this is Freddy, stargazer fish, one of the best coastal engineers on the planet. By injecting just a small jet of water pumped from its mouth out through its gills, it's able to liquefy sand and bury itself effortlessly underneath it. And that's how we do it. That's exactly how we do it. And here is the icing on the cake. We can apply the same nature-based principle to an existing wave energy technology to transform it into a resilient, affordable, and scalable technology. And the existing technology is really simple. It uses pressure variations from waves passing over air-filled membranes, forcing air through a turbine, which generates electricity. So this is the proven principle that has already been seen working in real environments for a number of years. The existing approach uses a huge 900 tons of structure to anchor the membranes. This is where our innovation comes in. What we do is just mimic Freddy the Stargazer fish you have just seen in the video before, to bury the membranes under the sand, getting rid of 900 tons of metal and cutting the costs accordingly. In August, we have successfully demonstrated our prototypes in the wave tanks of Imperial College. We have just reproduced results that had already been shown by several universities and startups in the past, but with our devices, which are 50 times lighter and 5 times cheaper at scale. So we're really proud of this too. And the result is that we can generate electricity for only 4 pence per kilowatt hour, which is cheaper than what we currently pay for fossil fuel energy. And it will help save over 200 million tons of CO2 annually at scale. There are plenty of locations worldwide where we can deliver these big impacts. There are over 40,000 kilometers of coastlines where the correct sediment types and wave energy resource work for our technology. So this is how we plan to go to market, first by demonstrating beach protection and with pilot projects and starting to commercialize that. On this way, we will reach positive cash flow. And while doing that, we will develop and ultimately commercialize wave energy technology. So this is our team. We met through a shared passion for coastal environments and the oceans. Together, we have 10 years of experience in the energy sector, the experience of creating several successful startups in the past. What doesn't exist in skills is knowing how to work with flexible structures under the seabed. So that's what we've been doing, and that's what we're currently doing, developing this knowledge and what we're continuing to do. So far, our many field and lab tests have taught us how to operate the flexible membranes under the seabed. We have, this has allowed us to file 2 patent applications, to join incubators, to win the prestigious climate tech startup competitions in Europe and the UK. And now, with what we've learned this summer, we're going to deploy operational prototypes on beaches in the UK and in France. We're currently looking for pre-seed funding to do that and to reach TRL 5 and starting generating revenue, allowing us to look for further funding. And that's it. So why continue fighting our oceans when all we have to do is work with them? And with WaveX, we see this future becoming reality. Thank you.
I love that. Thank you so much. And yeah, I love the concept of going with nature than trying to fight it. I think that's brilliant. And I think you must be the only company in the world, definitely the only company I've ever seen, that has got a fish on its board of advisors. That's amazing. Very much enjoyed Freddie's cameo. Thank you so much, Clement. And now, Mike from ACUA Ocean, are you happy to come and share with us what you are working on?
Absolutely. Thank you so much, everybody. I'm just going to try and get SlideShare up and then make sure I can do the technology first and foremost. There, hopefully that should work. Can you all see my slides okay? Perfect. Fantastic. Thanks very much, everyone. So Mike Tinmouth from ACUA Ocean. So moving from subsurface and energy generation up onto the surface of our oceans. And we're developing the world's first hydrogen-powered autonomous surface vessel or vehicle. So ultimately, what we see operating in the ocean space is a massive growing opportunity. And Cherry talked to some of the stats, the impressive stats around the size of the blue economy. What we're seeing is some of the drivers for this as well from a value perspective. And so we start off with growth in, we're living in uncertain times, but the maritime security sector, the protection of critical offshore infrastructure, wind farms, data cables, pipelines, and all of those sort of things are really becoming an issue. When we at ACUA sort of first went out and started talking to energy providers 2-3 years ago, saying, look, there's a stat: 95% of all of our data and our financial transactions go via subsea cables. Who's protecting these? And they went, well, is that really an issue? And then Nord Stream went bang, and suddenly the entire world's woken up to just how important the ocean infrastructure is, whether that's gas pipelines or data cables and the likes as well. So massive growing sort of space in maritime security, which also includes everything from sort of anti-narcotics, human trafficking, the likes as well of marine protection. So the growth through the High Seas Treaty and the sort of desire to move to 2030 by 30. So by the year 2030, 30% of our Earth's oceans to be fully protected. And this includes things like fisheries protection and the likes as well. So massive growth in maritime security, massive growth in the potential for offshore wind. So again, another ambition here in the UK was, and I think it's slightly on politics getting in the way of progress sometimes, but there was an ambition for around 30% of all UK households to be powered by offshore wind by the year 2035. So again, more and more sort of opportunities in this space as well. And then the massive growing sort of marine conservation and sort of blue economy space. So the idea here that, not only protection of your marine biodiversity, but also looking at new innovative ways to create financial models for sustainability. And this could be in the likes of biodiversity credits or blue carbon credits, which are becoming really interesting for small island developing states. So massive opportunity. And actually, the other thing that's sort of really massive when you talk about the ocean space is just how big and complex it is. And I think this is one of the things that a lot of people sort of going into ocean tech for the first time really don't realize, is that the ocean actually is an incredibly large, it's over 70% of the Earth's surface, but it's also an incredibly inhospitable environment, and actually a very much misunderstood environment as well. We know more about the surface of the moon and Mars, the surface of Mars, than we do about our Earth's ocean. So I think the stat coming out of, there's a conference in Monaco today called Seabed 2030, and the stat from this morning was that to date, we have only mapped 29.1% of the Earth's oceans. So there's a massive opportunity in terms of ocean data as well, but it's expensive and it's dangerous to operate in. And so this is where we really saw an opportunity to move towards autonomous systems. So lower cost, long endurance systems powered by green technology. And so our USV vessel, essentially a large drone, a 25-ton, so it's not small, it's not a bathtub toy that we're building, it's a 25-ton vessel that's built to go out into the ocean to conduct a range of activities, whether that is launch and recovery of subsea robotic systems, whether it's data collection, whether it's providing a non-lethal security service. Our vessel's out there to do that. And what it's looking to do is replace some of the other sort of technologies. So satellite technology is great as an enabler, but what it doesn't have is the ability to penetrate the subsurface. So the air-water interface, it's really almost impossible to get reliable ocean data from satellites below about the 20-meter mark. So you need a physical asset. Also, satellites aren't a deterrent. If somebody's going to do something illegally, they're not going to be worried about what a satellite might pick up. There are other alternatives in the market to us. So there are some of the wind, wave, and solar powered. So Sail Drone are a fantastic startup sort of based out of Silicon Valley in the US. They've very much been the industry leader, but what we've seen is the challenge there is wind, wave, and solar power is great from a clean, sustainable, long endurance, but what they don't have is power for payload. What this sort of market in this ocean space really needs is power to run sensors, to run AI edge-based processing of data. And then sort of the final one is, we're ultimately looking to replace really, really big, expensive vessels with smaller autonomous systems, moving away from those £1 billion. The new Type 26 Royal Navy frigate is £1 billion per vessel. Can we move that to a robotic system, which is only a couple of £1 million, that actually sort of goes and removes the need to put human beings into dangerous situations, whether that's conflict situations or just operating out at sea. So a little bit about us. We're a team of 13 now, and we're growing pretty rapidly. We're recruiting for 5 people at the moment. By the end of next year, we're sort of on target to reach a team of 25. So we've got a huge range of individuals, different backgrounds, different skills, different experiences, some coming from academia. So Puneet and Sol, both PhDs, but actually we've also found a lot of success working in the veterans community. So we've been a very, very active recruiter from the Royal Navy and the Ministry of Defence, looking to reskill people coming into the sort of technology startup space, but also particularly to use their skills in the ocean space as well. But we've also looked beyond ocean as well. So Charles joined us from the Mercedes Formula One racing team. So really diverse opportunities to take technologies developed in other sectors and deploy them into the ocean space. And just as I said, you know, the vessel itself, all about long endurance, all about powerful payload, all about cost effectiveness and ability to scale. And where we're at from a development perspective, you know, the life of a startup and an entrepreneur is a roller coaster. There's the old cliche that no 2 days are the same. I can tell you sometimes it's no 2 hours are the same, and you're 1 minute you're wearing one hat, and I think as a team we're incredibly sort of knowledgeable, but also incredibly nimble, and the ability, you know, one of the things that makes us very different to working in a corporate environment is the absolute ability to make decisions, to pivot on the spot, to actually pull together, you know, and deliver engineering and really cutting edge engineering as it is required. There is no long decision-making process. There is design, there's iteration, but we act and smart and nimble. And so from our side, it's also the diversity of the different types of technologies that are deployed that can be really, really interesting. You don't have to, in the world of autonomy, you don't have to have been to sea or want to go and sort of live on a boat for months on end. We've got a range of different skills that we deploy, from naval architects and mechanical engineers and systems engineers to the big sort of thing that looks a bit like a torpedo is our hydrogen tank. And sometimes I make the mistake of saying, well, it's not rocket science. Well, actually it is to some extent. It is much the same. We were talking to Chart Industries, who actually build the rockets for NASA and SpaceX. So sometimes it is rocket science. And what we also see, though, is a new set of sort of opportunities for individuals, as I said, who may not want to go to sea or who can't go to sea. So those who may have mobility impairments, or other sort of who may have other career ambitions that want to stay ashore. We're remotely operated, so this isn't also about replacing human jobs with you know, AI and entirely autonomous systems. We're creating new high-tech skilled jobs onshore primarily. And so one of the really interesting sort of concepts in the space we're in is around sort of who makes the right type of operator of a drone technology. And there's this kind of question that's posed of, do you train mariners to be computer gamers, or computer gamers to be mariners? And that's one of the things that which we've really reflected on, because actually having a knowledge of the ocean and the conditions in the ocean actually is really, really important to then piloting a boat that might be 2,000 miles away from where you're sat in a nice, warm, dry control center. At the same time, as you know, as the number of people who've gone to sea rapidly declines, so we're actually creating jobs that become very interesting to a younger generation who might have grown up in front of a games console, who are thinking, actually, how can I carry on playing computer games for the rest of my life? Well, actually, there are some incredibly well-paid, highly skilled engineering jobs being developed in the likes of USV operators. So that's just a little bit of a background on what we as a company do. I think that might be the last of my slides. So happy to hand back for any questions or breakouts.
Fabulous. Thanks so much, Mike. That was fascinating. Really, really interesting. And I love that stat about how we've only mapped 29% of the oceans. That's amazing, considering we've now got a telescope that's mapping galaxies hundreds of millions of light years away. That seems insane. But yes, thank you so much for that. It was brilliant.